Hello and welcome to another lovely edition of the program Teaching and Learning on Radio. Teaching and Learning on Radio is a program that comes your way every weekday on Prestige FM and some other radio stations. And it's brought to you by the Ministry of Education right here in Niger State. We have lots of subjects that we treat every week, every day of the week. We always try to see how we can give the students at home another opportunity to learn while they are home. You know, the pandemic is everywhere. The coronavirus pandemic is everywhere. And so the shutdown and the closure of schools and companies actually made the students are at home right now. Those preparing for WAEC, NECO, and other examinations, I think it's an opportunity for them to stay at home and learn while listening to radio. The teachers, the facilitators will be right here in the studio with us. They will tell us about a particular subject. They look at a subject and a topic, and the phone lines will be open for you to actually call in or probably send a message and ask your questions, and you will definitely learn something. So, well, it's for students at home, and it's brought to you by the Ministry of Education right here in Niger State. Teaching and learning on radio. Teaching and Learning on Radio it is. Well, today we have lots of things to learn, and we have our facilitator in the studio. You're welcome.
Hello listeners, you are welcome to this edition of online lesson. We are going to look at the subject mathematics. And mathematics, as you all know, in WAEC, NECO and NACTEP is divided into two papers, paper 1 and paper 2. Paper 1 is made up of objective text, and paper 2 is essay part. The essay part is divided into two parts. Part 1 is compulsory, which has 5 questions. Then part 2 has 7 questions, which you are expected as a candidate to answer 5 questions. All in all, you are expected to answer 10 questions in the second part of the mathematics. Today we are going to look at surface area and volume of a sphere. By the end of this lesson or presentation, you are expected to be able to calculate 1. Surface area of a sphere, 2. The volume of a sphere. First of all, what is a sphere? A sphere is a solid shape with perfectly round surface. Examples of spheres include balls, orange, globe. Like I said earlier, our main focus today will be on surface area and volume of a sphere. The surface area of a sphere is given by the formula 4 pi r square, while the volume of a sphere is given by 3 over 4 pi r cubed. The unit for surface area is square unit, while that of volume is cubic unit. Listeners at home, we are going to take example on how to calculate the surface area and volume of a sphere. Let's take a look at this problem. But before we do that, we are going to use some abbreviations throughout the presentation of this lesson. The abbreviations include 1. We are going to use V for volume, S for surface area, R for radius, and pi will have the constant value 22 over 7 or 3.142. Approximately, that is what we are going to use. Let's take a look at this problem. Example 1. A sphere has a radius of 8 cm. Find its surface area and volume. For us to find the surface area, remember we said the surface area is given by the formula 4 pi r square units. And in the question we are given radius to be 8 cm. Radius 8 cm. Now, if we want to find the surface area, we are going to substitute for r, which is the radius, and for pi, which is 22 over 7. Therefore, for us to get the surface area, we are going to have S equals to 4 pi r square, where pi is equal to 22 over 7, and r, which is our radius, is 8 cm. Substituting into the formula, we are going to have 4 times 22 over 7 times r, which is 8 square. 8 square gives us 64. we are going to have 4 times 22 over 7 times 64. By the time you multiply 4 by 22, you are going to have 88 times 64 all over 7. And by the time you multiply 88 by 64, you are going to have 5,632 all over 7. And when you divide 5,632 by 7, you are going to have 804.57 centimeter square. And that is the area of the sphere with radius, surface area of the sphere with radius 8 centimeter. I hope listeners at home are following. So if we are able to get the surface area to be 804.57 centimeter square, in case we are asked to round up to the nearest degree, or to the nearest whole number, or to the nearest significant figure, we can do that. But as far as this lesson is concerned, I want to round up to the nearest 1 decimal place. I want to round up to the nearest 1 decimal place. So I'm going to have 804.6 centimeter square. That is the surface area to 1 decimal place. Now to calculate the volume. I have told you earlier that the formula we use in calculating the volume of a sphere is 3 over 4 pi r cubic units. So since our radius is known to be 8 centimeter, substituting for radius and the pi, we are going to have the volume V equals to 3 over 4 times 22 over 7 times 8 to the power of 3. By the time we do this, we are going to have, volume is 4 over 3 times 22 over 7 times 8 to the power of 3. By the time we do that, we are going to have 4 times 22, which gives us 88 over 3, then times 8 to the power of 3, which will give us 64 times 8 all over 7. By the time we reduce, we are going to have 88 times 64 times 8, we are going to have 5,632 times 8 all over 3 times 7 gives us 21. And if you divide 5,632 times 8 divided by 21, you are going to have the volume to be equal to 2,145.5 centimeter cube. And that gives us the volume of the sphere with radius 8 centimeter. Listeners at home, I hope you are following. If we are asked to calculate the surface area of a sphere, we are expected to use the formula 4 pi r square unit. And if we are asked to calculate the volume, we are expected to use the formula 4 over 3 pi r cubic units. That brings us to the end of the first question. I hope you are following. Okay, now we are going to take a look at another example that has to do with the surface area and volume of a sphere. Now let's take a look at this question. The question says that a sphere of radius 2 cm is of mass 11.2 gram. Find 1. Surface area of the sphere. 2. The volume of the sphere. 3. The density of the sphere. 4. The mass of a sphere of the same material but with radius 3 cm. Take pi to be 22 over 7. For us to solve this problem, remember earlier I have told you that surface area of a sphere is given by 4 pi r square unit. We are going to apply the same formula in solving this problem. But remember that the radius given in the first question was 8 centimeter. And the radius given in this second question is 2 centimeter. So we are going to use our r to be 2 centimeter. So surface area, which is S, is 4 pi r square, where r equals to 2 centimeter and our pi is equal to 22 over 7. Substituting into the formula, we are going to have S equal to 4 times 22 over 7 times 2 square. 4 times 22 gives us 88 times 2 square gives us 4. all over 7. By the time we multiply 88 by 4, we are going to have 352 all over 7. And if you divide 352 by 7, you are going to have 50.2857 centimeter square. And if we want to approximate to 1 decimal place, we are going to have 50.3 centimeter square. And this gives us the surface area of a sphere with radius 2 centimeter. This will now take us to the second question, which asks us to find the volume of a sphere with radius 2 centimeter. And remember, we said volume, which is V, is given by 4 over 3 is given by 4 over 3 pi r cubed. And from the question, our r is 2 centimeter and our pi is equal to 22 over 7. Substituting into the formula, we are going to have V equals to 4 over 3 times 22 over 7 times r, which is 2 to the power of 3. If we simplify further, we are going to have 4 times 22, which will give us 88, times 2 to the power of 3 means 2 times 2 times 2 times 2, which will give us 8. So we are going to have 8. Then we multiply the denominator, which is 3 and 7. 3 times 7 gives us 21. By the time you multiply 88 by 8, you are going to have 704 all over 21. And if you divide 721 by 4, if you divide 704 by 21, you are going to have 33.5238 centimeter cube. Now I want to round up to the nearest 1 decimal place. Or I want to round up to 1 decimal place. If I want to do that, I'm going to have 33.5 centimeter cube. And this give me the volume of the sphere with radius 2 centimeter. I hope listeners at home are following. The next question asks us to find the density of the sphere. If you could cast your mind back to the topic, we said we are looking at the surface area and volume of a sphere. At times, when you are solving problems that have to do with a sphere, you will see a different thing coming in, just like what this question demands from us. The question asks us to find the density of the sphere. And the density is given by the formula mass all over volume. That is the formula we use in calculating the density of a sphere or of a shape. Are we together? So what we are going to do now is to calculate the density. And from the question, we are given the mass to be 11.2 gram. Sometimes the mass could be in kilogram or in gram. As far as this question is concerned, the mass is in gram. So we have our mass equal to 11.2 gram, and we've already calculated the volume. And we said the volume is 33.538 centimeter cube. So if our volume is 33.5238 centimeter cube, and we know the density is given by mass over volume, then we substitute for mass and volume. And for us to substitute for mass and volume, where we see mass, we put 11.2 gram, and where we see volume, we put 33.5238. And by the time you divide that 11.2 gram by 33.5238 centimeter cube, you are going to have 0.334 gram per centimeter cube. And that gives us the density of that material. I hope listeners at home are following. The next question asks us to find the mass of a sphere of the same material but with radius 3 centimeter. You know, the radius we've been using was is 2 centimeter. Now they want us to calculate the mass of the same material but with another radius 3 centimeter. Let's see how we're going to do that. Since we are given radius 3 centimeter, we are given radius to be 3 centimeter, different from the radius we used earlier to calculate the volume. Let's see how we can calculate the mass. For us to calculate the mass, you know density is equal to mass all over volume. And for us to get our mass, we need to make mass the subject of the formula by cross multiplying density by volume. So if we make mass subject of the formula, we are going to have density times volume, and that gives us our mass. And you remember that we need radius. Already we know our density, but we don't know volume of radius 3 centimeter. That means we are expected to calculate the volume so that we'll be able to get the mass of the material when the radius has changed from 2 to 3 centimeter. Now let's get the volume. And you know the formula for calculating the volume is 4 over 3 pi r cube, where r equals to 3 centimeter, and the value of pi remains 22 over 7. If we substitute, we are going to have volume equals to 4 over 3 times 22 over 7 times 3 to the power of 3. If you multiply 4 by 22, we have 88, and if you multiply 3 to the power of 3, or you expand 3 to the power of 3, you are going to have 3 times 3 times 3 times 3, and that gives us 27. So you have 27 all over the denominator, which is 3 and 7. 3 times 7 gives us 21. And if you simplify further, you are going to have volume to be 88 times 27. 88 times 27, and that's divided by 21. You are going to have 113.143 centimeter cube. That gives us the volume of the material with radius 3 centimeter. Now, since we've gotten the volume to be 113.143 centimeter cube, and we've already calculated our density to be 0.334, then it's easier for us to get the mass, because mass is density times volume. I hope listeners at home are following. Now let's substitute mass, which is density times volume. What did I say the density is? I say the density is 0.334. 0.334, since we are using the same material. So 0.334 times the new volume, and the new volume is 113.143 centimeter cube. Then, for us to get our mass now, we multiply 0.334 by 113.143. We have our mass to be 37.79 gram. 37.79 gram. That is our mass if the radius changes from 2 centimeter to 3 centimeter. Listeners at home, this brings us to the end of question 2, which asks us to find the surface area, the volume, the density, and the mass of a material with radius 2 centimeter and mass 11.2 gram, and later the radius changes from 2 to 3 centimeter. I hope you are following. Now, at times in examinations, you will be given the surface area, you will be given the volume, and you will be asked to calculate radius. So in case you see any question that looks like that, what you need to do is to make either the surface area the subject of the formula to get your radius, or you make the volume the subject of the area, and get the radius. So what we are going to do now, subject of the formula, sorry. What we are going to do now, we are going to take a look at this problem. The question says, that is question 3 now. The question says, find the surface area of a sphere. Or the surface area of a sphere is 544 centimeters square. What is the volume of the sphere? The question says, the surface area of a sphere is 544 centimeters. What is the volume of the sphere? If the surface area, which we tag as S, is equal to 544 centimeters square, and we are asked to find the volume, then what is the formula for calculating volume? We say volume is 4/3 pi r cubed. And if we are to go direct in solving this, we need radius. And for us to solve and get radius, what we need to do now is to put the formula for calculating surface area. That gives us 4 pi r square equals to 544 centimeter square. Then when we divide both sides by 4, we are going to have pi and r square equals to 544 divided by 4. And by the time it's 55,000. 5,544, not 544. That is the surface area. So by the time we do that, we divide 5,544 by 4, we are going to have 1,386 here, and we are going to have pi r square. And we divide pi by both sides. If we do that, we are going to have pi r square here, divided by pi. We are going to have 1,386 divided by pi. This pi will divide a pi here. And we are going to have radius square equals to 1,386 all over pi. And we know the value of pi to be 22/7. If we substitute for pi 22/7, we are going to have 1,386 divided by 22/7. Then when we reciprocate, we are going to have r square equals to 1,386 times 7 divided by 22. And our r square will be equal to 441. And by the time we take the square root of both sides, we are going to have r equals the square root of 441. And our r now will be 21 centimeter. Once you have your r, you can get your volume. And the volume now, if you substitute for r, you are going to have b equals to 4/3 times 22/7 times r, which is 21 to the power of 3. If you simplify further, you are going to have 4 times 22, 88. 21 to the power of 3 means 21 times 21 times 21 3 times, and that will give us 9,261. Then when you multiply the denominator, you have 3 times 21 times 7 give us 21. And by the time you multiply 88 by 9,261, you are going to have 814,968 divided by 21. And by the time you divide 814,968 by 21, you are going to have 38,808 centimeter cube. And that is the volume of the sphere. Listeners at home, I hope you are following. Let's quickly go back to where we started. From the beginning, we look at the sphere, and we say a sphere is a solid shape with perfectly round surface. And from there, we proceed to the area of sphere. And we say area of sphere is given by 4 pi r square unit. And we say that the volume of a sphere is given by the formula 4/3 pi r cubic units. Now, let's see how you can use these formulas stated now to solve problems. I hope you are close to your biro and exercise book. If you have that close to you, jot down the following questions. 1. Find the radius of a sphere whose surface area is 154 centimeters square. I will take the question again. Find the radius of a sphere whose surface area is 154 centimeters square. you can see and check the result from Progressive Mathematics Book 3, page 20. And there are other questions there. Until I come your way again, you can also check or join us on WhatsApp number 09029282040. Again, 09029282040. Until I come your way again, I remain Abubakar Mohammed Indanusa. Thank you very much.
What class is this?
SSS.
That was a wonderful presentation by our facilitator. He taught us a whole lot, and I learned as well, so I believe you've learned something this lovely edition of the program, Teaching and Learning on Radio. Well, join us again next time, that's tomorrow. Join us again and for another lovely edition of the program. You never can tell the subjects coming up, so just be on the lookout. And children out there, and not just children, parents, I urge you to encourage your children to listen to the program. As they stay at home, they learn as well. All right, thank you so much for watching and listening. Bye-bye.